Hi, everyone, and welcome to this exciting hands-on lab. My name is Victor Martin, Technology Product Strategy Manager, and we are very excited about this workshop based on the collaboration between Oracle Cloud and Red Bull Racing Honda. During the next 2 hours, you will build a machine learning model and integrate it in a Python application running on OCI to predict the top 5 drivers of a Grand Prix. This is a machine learning entry-level workshop, so we don't expect you to know much about machine learning. The whole content takes more time to execute than the 2 hours we have today, and that is why we provide all the notebooks, and they are all executed for you. I will walk you through the code of the Jupyter notebooks, but feel free to follow along with me. The most important takeaway for this workshop is that you understand the process of implementing this machine learning model and to put it in production. To take even more pressure off you, our panelists will get you out of trouble through the Slack channel, as Ettore mentioned. First, I'd like to introduce some folks that are helping in today's workshop. As I mentioned, I will be your guide today. We will also have other panelists that are going to answer questions for you behind the scenes. Ettore is head of developer marketing for EMEA. Melanie is master principal sales consultant on the Oracle Solution Center. Priscilla Iruela is technology product strategy director. John Craig is technology strategy program manager. Paola and Rawan are technology product strategy manager. Roxana and Javier are senior data specialist, cloud engineers on the data management. Piotr is domain specialist cloud engineer, data management, and Tim Graves, OCI specialist director. Thank you all for your support today. Before we start, here we have the resources needed for today's session. Check now as well on the Zoom chat section, as Ettore mentioned, to grab the links, but you can also type them on your browser directly. Before today's session, we send you an email with a request to fulfill some prerequisites, including a video with a sign-up process for the Oracle Cloud account. I will start a poll now to see if you have completed the prerequisites. If you have done that, that's great. Thank you. You are already ahead of the game. If not, you have to do it right now. So let us know on the poll so we can allocate more time for you. On the poll, we are checking how many people have already completed. So yeah, pretty good indeed. On the screen, you can see the bit.ly link for the sign up for the Oracle Cloud account if you still have not signed up for Oracle Cloud. The second one is the link to the workshop guide step by step. And finally, the link to the Slack channel for Q&A. Please join us now in that Slack channel and say hello. Let us know your country as well if you want. And that Slack channel will be the place to ask for help. So if you join now, it will be way better than when you have a question and you are like rushing through the content. For those that haven't signed up for the Oracle Cloud account, please follow the first bit link and sign up now. We have excluded your email, so using the email that you have for the registration, and you can avoid a few verification steps during the sign-up process. We will also give you 500 euros instead of the traditional 300 euros to consume during the 30 days trial period. You will not need a credit card for the verification of your account if you follow those steps. In case you need it for any reason, you will not be charged unless you explicitly tell Oracle Cloud to upgrade to pay account. So you are safe. For those of you that have already completed the prerequisites, thank you so much. Bear with me for a few seconds. Meanwhile, I give you a brief overview of the workshop. Here is the agenda for today. Let's jump directly on an overview of what we are going to see. So this is the overview of what we are going to do today. Basically, we are going to follow the data pipeline typical for machine learning. So we are going to do data collection, meaning that we are going to extract information from formula1.com, from Aircast API that provides information about races in the past, and Wikipedia for weather on those days, on those specific circuits. Then we will step into the number 2, data preparation, where we will start merging all of that data in one single data frame and also clean that information a little bit. The next step will be the data exploration, meaning searching insights on that data, start plotting some graphics so we can understand how the data is laid out. The fourth step is implement and develop different machine learning algorithms and evaluate which one is the best. In the step number 5, we will take that best algorithm and deploy it and expose it through a REST API. And the final step, we have give you a web application that you can deploy and then use that REST API with the model to have the predictions. By the end of this workshop, you will deploy this Python application that allows you to select the circuit and the weather conditions. The machine learning model will give you the predictions of the top 5 drivers in those conditions. We are going to walk you through these notebooks, so don't worry for the different labs. So let's get started. The first item for the agenda is the provisioning. It's very important because at that point you can have access to the cloud and then start working with the rest of the content. So let's watch a quick video that walk you through the steps of the sign-up process for those of you that haven't have a cloud account already. If you want to watch the video, great. If not, no pressure. Go straight to the workshop guide to find the documentation covering how to generate an SSH key and the stack that provisions the environment. That will be the first step. Everyone needs to do those steps to have the notebooks and the Python application. So feel free to start if you have your Oracle Cloud account fully provisioned.
Hi, I'm Victor Martin from Oracle Cloud. I'm going to walk you through the steps to sign up for an Oracle Cloud free tier. Please follow along and pause the video when you need it. Oracle Cloud free tier gives you a set of always free cloud services. These services will be available forever. 2 autonomous databases, 2 virtual machines, up to 4 ARM processors virtual machines. You will also have a load balancer, block, object, and archive storage, monitoring, and much more. As part of your Oracle Cloud free tier, you will also have a 30 days trial with free credits to use in other services from analytics to Kubernetes. Sounds good, isn't it? Are you signing up for an upcoming workshop with us? Please make sure that you use the same email you use for the registration, as we have activated a special offer and you won't need your credit card to sign up. In any case, Oracle Cloud is not going to charge you for your trial. You actually have to explicitly tell us so when you are happy with all the Oracle Cloud services after your trial. Let's dive in. You need to add your country. Then your first and last name. You also have to provide your email. Oracle Cloud has to check you are a human by asking you to resolve an easy challenge. Finally, click Verify my email to move to the next step. If your email has been activated for the offer, you will see the special Oracle offer pop-up window with the type of offer already selected. Then click Select Offer. All the initial information is already in. Now you have to provide a strong password. I use a generated one, but you can select any you like. Just make sure you are in compliance with the strong password pattern. Confirm the password by typing it again. Fill the company name if apply. The cloud account name is essential as it is a unique identifier for your account. Select a name you like that is not taken. The home region is the region where you are more likely to deploy resources. You can deploy to other regions by subscribing to them. However, your free trial only supports one region. Select a region geographically close to you if you are not sure. I'm selecting Frankfurt region. At the bottom, click Continue. Fill the address information with city, postcode, county, and your phone number. Click Continue. The final step is to accept the agreement and click Start My Free Trial. Oracle Cloud starts provisioning your account. This takes on average 1 minute or 2. Then you are going to be redirected to the Oracle Cloud web console. Can you see the message "Your account is currently being set up"? It means that some services will still be unavailable for a few more minutes. Just keep it in mind. When Oracle Cloud fully provisions your account, you will receive an email. I will show you that in a few seconds. Go to the menu to explore Oracle Cloud services. Also, the search bar is a friendly tool as you can search for compute instances, Kubernetes engine, analytics services, cost tools, user management, autonomous databases, Apex instances, and much more. On the right side, you will see the region you selected when you sign up. The next icon is Cloud Shell, a small free Linux instance with several tools pre-installed and configured like OCI CLI and languages like Java, Node, Python, and more. You can close Cloud Shell now, confirm with Exit. The next one is Announcements for updates from Oracle Cloud. The following is the Help icon, where you can find documentation links, chat with us, post questions in our forums, and finally, create a support request and request a limit increase. The next icon is to change the language, and the final one is the Profile icon, where you can see your user information, your tenancy, and the Sign Out button. After a while, the message saying that your account is being set up will disappear. After a few minutes, you will also receive a Getting Started email and another one when your trial account is fully provisioned. Use the button in the email to sign in whenever you want in the future. You are all set up to enjoy your new Oracle Cloud account. Happy hacking!
Perfect. Let's jump into the generate SSH key. That is the first step. I have to say it's optional, but it's a good practice to know how to do this. So I have to share the browser, so you will see how I'm doing that. This is the content of the lab. So basically, you can open the different steps and go through them. I just want to copy one specific one that I am going to need, and I don't want to write on my own. So I copy that and come back to the Oracle Cloud Console. Everything was explained on the video, so I will jump directly into the Cloud Shell. And this is where you are going to generate the SSH key. It's a Linux environment, so it's a nice way to not have to install things on your computer. You can use the tools here. So I'm going to execute that. It's going to ask for a passphrase, but basically I want to leave this empty. So empty and confirm that I want it empty. And then I can list and see that I have two files. One that is the private key, Cloud Shell key, and another file that is the public key, public Cloud Shell key.pub. That is the one we want to list to show the content, and that is the one we are going to use in the next step. So we can print that on the screen, and I can do that because it's the public one, so there is no risk on security. And I just copy exactly all the text that I need. So let me go there. Be extremely careful with this because you can copy a little bit more of a character and then like those empty characters that you don't see and you can get into trouble. But just make sure that you copy that text. And
Victor,
then,
sorry to interrupt you. Can you zoom in a bit?
Absolutely. Yeah, the font size is really small. Yeah. So
thank
basically
you.
what I'm doing, yeah, thank you, Ettore. Jump at any point and tell me how the Q&A is going as well. But the cut is to print the content of the file. So this is the content, I copy that content, and that is everything you have to do for that first step on the generate SSH key. So in this case, we can come back to the presentation. And in this case, we can go to the next step. You can do it on your own, don't worry. And then we can jump into the next step of the agenda, that is the create a stack. using Resource Manager. That is basically a Terraform package with all the information, all the environment for today's workshop is there. So let's jump into that. Let's come back to the browser. And here in the browser, we can just take a look to how it looks like. It's lab number 1, create a stack using Resource Manager. I click there. And then the first step, and very important, is this button, the deploy to Oracle Cloud. That is the one that is going to kick off another tab on your browser and is going to redirect you to the wizard to create all of this. I have already all of this running, but I want just to walk you through the steps. So the first step, and once again, everything is on the lab content, so you can go through that, read, or just follow along my explanations. It's up to you. As well, I want to remind you to join on the Slack channel. Okay, so I will tell you to go to the chat section and make sure that you join the workspace and you join the Slack channel, specific channel for the session, in case you have any question moving forward. So the first step, you are here in the stack information to create a stack, and we are going to accept the terms of use, and then everything will be populated for you. You really don't have to change anything. The root compartment, it's okay. It's the way to go. The root compartment will be created for you by default, so you don't have to do absolutely anything, and then you can go next. Configure variables, and here is where you have to paste the SSH key. So you can paste it and make sure that there is no strange characters at the beginning or at the end, and then you can go next to review and confirm with create. Make sure run apply is already selected, because that will apply the Terraform script and just create all the environment for you. You don't have to do anything. You click create and happy days. I'm going to show you how this looks like. So you will end up in this stack that I have here, and the apply will be working. So it will be in provisioning at some point in time, and this takes around, I would say, 10 minutes. You will have the succeeded for the apply job, and that means that you have the instance up and running. If you have any problem at this point, it's usually because you are using or reusing another trial account that is not active, that you have a pay-as-you-go account that has no enough resources available, things like that. So in that case, let us know in the Q&A, but I recommend you to go for a fresh free account on Oracle Cloud, and that will minimize and streamline your process. You can, if you have any issues, you can copy the error message that you have in the logs, and that is pretty much everything you need for the stacks. The next step on this lab is to go to compute. So for that, we go to the menu, compute, instances. And once again, everything is explained step by step on the guide. But basically, at this point, you won't see an image, an instance. And that is because you are in the root compartment. So make sure you go here, open it, and check the Red Bull hole. If it's not there, refresh the browser. Sometimes take a while to refresh those. Refresh the browser, and you will have it there. As soon as you click the Red Bull hole compartment, the instance will be there. And then we will have here the public IP. You will have a different one. So use your public IP. I'm going to open another tab, paste the public IP that I have, but yours will be different, and then you have to write the port. So semicolon 8001. That is where our Jupyter notebook is listening. There will ask for passwords. So let's put this a little bit bigger, and as well in the documentation, you will find the password, but the password is Red Bull 1 with the R in uppercase. Don't save, and then you will land into the dashboard of the Jupyter notebooks. As you can see, all the notebooks that you need for today are already there. And I want to call out the attention in a couple of folders. One is from scratch. So I don't recommend to run any of those because some of those take a little bit of time. So we have run them for you. but for the specific ones that you can run and test it, they are in from scratch. So if you want to test it from scratch, you can open them and make sure that everything works for you. And there is another folder that I will mention nearly at the end. That is the res. That is the results, because there are some parts that are left empty, and you have to fill that. If you get stuck for whatever reason, the solutions are there, so feel free. And that is all for the stack. This takes 10 minutes, so leave it working. When we continue working on the rest of the content, I'm going to come back to the presentation and go to the next step. That basically, we will give you 5 minutes to generate the SSH key and kick off the creation of the stack. Leave it provisioning, as I mentioned. It might take a few minutes. Post your questions on the Slack channel, and see you in 5 minutes. let's see how all of you are doing. Let's launch a poll to check if you have completed the generation of the SSH key and you kicked off the creation of the stack. I know this could be like a fast-paced, but as soon as you have the stack already up and running, that means that you will have all the content, all the code, and you can just do all the work on your own time. The most important part and key takeaway for this event is that you understand how to implement it, how to everything lay out, and then you can take a look to the details on the code. So Ettore, if you can launch the poll for this state. So please answer and tell us if you have completed lab 1, create a stack. Even if the stack hasn't finished, that's okay. It will take a few minutes, but as long as you are moving in that case and the team is going to help you on the Slack channel, that's okay. You can move forward with me on the rest of the content. So we are going to jump into the data collection. That basically is going to be an important step to just get information from the different places. I'm going to show you how to do it, and then you can do it on your own. If you are moving ahead with me at the same pace, that's good. Then you can execute the code, but feel free to go either way. Cool. We have a 50-50, what is fine. Let's jump into the data collection. You can leave it, the stack, you can leave it up and running. That is not going to affect, and you can just pay attention to the next steps of the data collection. Let me jump into the browser once again, and I'm going to show you how the data collection is. So we cover the onboarding for the notebooks, where all the folders are, so on and so forth. What I want to show you is that if you go to from scratch, when you have the stack, you have login and so on, you will see that there are the 0, 1, 0, 0, 1, 1, and let me put this a little bit bigger so you can follow along. 0, 1, 2. Those are the 3 that belongs to this data collection. And we are going to open one by one and go through the code. So in this case, this is Python with several libraries that we are going to import. And something that I want to explain, if you are new to Jupyter Notebooks, you can run cell by cell. So these are cells that you can execute. You can do it with the play button one by one, and it's going to execute one by one. But you can also execute the whole notebook with this one. This is going to restart the kernel, that basically is clean all the information and start from the scratch and execute the whole content. If you do that, you will see that Python 3 ILD will move to Python 3 BC. And that is the indication that things are being executed, just in case there is no feedback or looks like what is going on. But that is a nice way to check if the notebook is being executed. I'm saying that because some of the steps takes a little bit of time. Remember that we are doing the data collection, so we have to wait for the request to come back from the different services that we are pulling the information from. So let's cover a little bit of what we are doing. Basically, we are using the Earth Gas API, that basically is a free service that has information about Formula 1 races, qualifying, drivers, so on. And basically, if you take a look here, we are going to ask for all of this information, and we are going to do it in this URL. So that URL contains the information of the different things that we want, and we are going to do it by year. So that's why we create a range from 1950 to 2021, and we are going to pull all of this and inject that value into this part. And that is going to give us information for that specific year. We are going to do all the mapping, getting the information from the seasons, the rounds, the circuits, so on and so forth. And finally, at some point, we are going to create a pandas data frame. That will be our data set for that specific races. And we are going to start playing around with the information. So we are going to print some of the information so we can see how the information looks like. That is already part of understanding your data. And then we are going to store that information in files as a temporal storage for that information. So races will be in data races, CSV file. And then we will jump into more to drill down into different details of the data, that we are getting. So we are going to get the same for the rounds. The results of that will be different. You see, we changed the URL. Other than that, it's the same thing. We are going to go through the rounds and get that extra information, drilling down into the details of the information. More mapping, just getting the information from the response inside of our data frame. And then we are going to create, once again, the data frame from pandas. No big deal. And we are going to continue doing that for drivers, standings. You see the structure of the code, the URL with a different URL, and then the mapping, and then storing with Panda the information as a data frame. No big deal. We are going to start working on that information, printing it, understanding how it is, and then store it as a temporal file in a CSV file. We are going to do the same with the teams, nothing new. So that's why you don't really need to wait for the stack to complete. You can understand the code, and then you can do it on your own time. We are going to do the same for constructors, trying to find information that we are interested. And then we are going to just print the time that it took for me to execute this. All good. And with that, we will get all the information from Earthcast. That means all the information from the races, the years, and the different rounds that happen on that specific race. For the weather, that is another file that you have there from scratch that you can run if you want, but if not, it's fine. We are going to follow the same structure. We are going to do the imports for the different libraries. Just to call out the attention, we are going to use a new one that is Selenium. Selenium is a way to web crawl a website that basically is going to the website and start extracting information. We are going to use HTML and CSS tags. So basically, we are going to find different pieces of information that is on the website. In this case, is the weather. So we are going to jump into Wikipedia. We are going to ask Wikipedia what was the weather in that specific area. And in that case, we are going to have this type of information, rainy, warm, dry, sunny, so on. We are going to print the end, the tail of the information, just to see how it looks like at the end of the data frame. And then we are going to start making a little bit of mapping, because some of the information is in different languages with different expressions that means the same. So basically what we are going to do is to translate that in a table. That is the one we print here, weather data frame. And we are going to print the beginning. And it's basically a table when it says 0 or 1, true or false, if the weather was warm, cold, dry, wet, and cloudy. That is the most important part. Different weather conditions that affect the temperature of the circuit, the temperature of the wheels, the type of wheels that you are going to put, the tires, and depending on that, the car will perform in different ways. So we can continue just inspecting the information. We are going to concat that information, so we have everything in one single data frame. And at some point, we are going to do exactly the same as we do, store that information in a CSV file as a temporary storage for us to recover in the next stages. We know how to run it. We have the information of the Formula One and also the weather. We are going to get the information from the qualifying, and the qualifying is information that we extract from the Formula One website. Nothing new here. We are going to have a URL from Formula One, getting the results, and we are going to extract that information into the data frame. And at some point, we are going to start printing that information, getting information from the different drivers and cars and the timing and the session and the round. With that information, we can start getting into the nitty-gritty of the hands-on lab. And no surprise, we store the information in a temporary CSV file, qualifying CSV file, and we are done with this step. So basically, it's very simple. We are just pulling the information from internet, getting some of the information we are going to analyze, and we can just move back to the presentation for the next steps. the next step on the agenda is the data preparation. So Ettore, let me know if there is any outstanding question on the Q&A that you want me to address live. This is a nice pause in case you are following along and you want to continue.
Not at the moment, Victor. So there are guests that are raising questions in the Slack channel, in the dedicated Slack channel that I invite you to join, all of you. Also because the Slack channel will be there also after the end of the session, so you can be in touch with our expert, with Victor, also in the upcoming days. So don't hesitate and join that Slack channel. Thank you, Victor.
I will definitely join after I finish the speaker part, and I will answer any particular outstanding questions. So feel free. That is an open channel for you, as Ettore mentioned. So feel free. Let's jump into the data preparation. We were talking about data collection, so getting all the information, and now it's time for the data preparation. That basically is self-explanatory anyway. But in this case, what we are going to do is just to understand those files that we have with that information and start aggregating the information. So let's come back to the beginners. And we have to go to the 02 data preparation. Let me open that one, and I'm going to close the ones we already work on. Data preparation is about merging all of those files that we have and start cleaning that information, making it easy for consumption for the next downstream workflow part. So let's understand. We are going to read CSV files that we already pulled from the data collection part, traces, results, qualifying, etc. And then we are going to start printing how that information looks like, so we understand what type of variables, the size of that, how many data points we have. And at some point in time, when we are okay, we are going to rename some of the columns to friendly names. We are going to drop some columns that we really don't need, we are not going to use, and then print the information, feel familiar with the information we want. And then at some point, this one is the important one, we are going to merge the information. So for those of you that have some knowledge on relational databases, what we are doing here is just a simple merge between two tables, races and weather, for example, in the first row, and it's an inner join on those specific key values, the season, round, and circuit. And then we are going to do the same with what we have from before, the F1, with results, with an inner join. And we are going to continue doing that, merging results, driver standings, constructor standings, and qualifying. That means that the final DF, the final data frame, will contain absolutely all the information we need. We are going to print it, nothing new there, and then we are going to start making some transformations. The transformations that we are doing is basically calculating the age of the driver, making conversions of the data times. At some point in time, we are going to drop as well the nulls, information that really doesn't give us any information, and make sure that it's nice for consumption in the next steps. Convert booleans, the typical cleaning of the data that we have to do in this data preparation stage. At some point in time, something interesting, for example, that we are doing is to work with the nationalities, the constructors, the circuit tree, dropping some columns that we don't need, so on. And then at some point, we are going to store the final version of the information with the data frame in a CSV file. That is the way we just leave that ready for the next step. And nothing new. Once again, we are going to print how long it took to run this. And that is all for data preparation. So we can come back to the presentation mode. And here in the presentation, we can move to the next step in the agenda. So once again, I want to really mention this a few times. This is about you learning, understanding the code. Then the code is there in your free trial account. You have 30 days to spend time with the code, change the data set, change the information, reuse the code, do whatever you want, change the way the Python code is written. So it's very important for you to just follow with me, understand how it's laid out, and then you can do whatever you want with that information. Data exploration, this is the next step. So let's come back to the browser. And with this step, let me get the guide that I have. In data exploration, we are going to open a new file, and that new file, let me get the okay. This is when you don't see the mouse and you have to guess where you are. So let me open the EDA, basically the exploratory data analysis. That is basically the data exploration part. And here I want to explain a little bit about the information that we have on the Formula One. So if you are new to Formula One, basically there is always, unfortunately, there is always a dominance in a constructor and a driver. There is a little bit of background information you need to understand the data set. Basically, there was a period where Michael Schumacher, Alonso, Vettel, or Hamilton are the dominated drivers. Basically, there was a big change in 2013 where we changed from the beast roaring V8 engine to the hybrid era. So we moved to a V6 engine, and that is the power unit that is composed for the electric part and the combustion engine. And that is from 2013, what changed a little bit, but basically everything that happens from 2010, I would say, to now is kind of more or less stable in terms of results, how the qualifying was done, so on. So now that we understand a little bit about the background of the information, it's time to jump into the code and understand that we are just doing the same with it. This is just briefly doing the same step that before, so you can understand is read the CSV files, merging the information, and then printing the information, nothing new there. We are going to do a small cleanup. This is all the columns we have after all the merging. That is too much. We are not going to use all of that information. So one of the cleanups to further drill down into the information that is really relevant is to drop those columns. And then if we print the columns after the drop, we will see that we have only the information we need, what is way more interesting. And then I want to cover as well some information about the Grand Prix structure. So this is the weekend of the race. What is happening is that we have 3 days, Friday, Saturday, and Sunday. Sunday is the day of the race. That is what we are trying to predict, who is the top 5 drivers on that Sunday morning. And then we have the Friday, that is like a free session where they can just tune the car, set up the different configurations of the car for the circuit. And then on Saturday, we have 3 sessions that are Q1, Q2, and Q3. All drivers join Q1. They go for the best time, and the 5 slowest, they are eliminated. The rest are moved into Q2. Q2 will have less drivers, and they will go for, once again, the best time lap. The 5 drivers, again, that are slower, they will be eliminated, and they will be in that position for the Sunday race. And then the rest will move into Q3, where we have 10 drivers, the 10 fastest, and they are going to, once again, go for the best and fastest race lap time. And basically that will compound the grid. And that is the position of the cars for the Sunday session. That is the race. So if you understand that, that is what we are analyzing when we are going through the data that contains the qualifying information. And after that, we are doing further cleaning. We are considering only data points from 2010 because it's the period where it's more relevant and is kind of the same type of Formula One in the last 10, 11 years. There is a big change coming next year. So 2022 will be completely different. For those of you that don't know about Formula One, the big change is that because there is that dominance and usually there is not a lot of action sometimes on the race, because the air that the car in front of you generate is creating a lot of turbulence and making it really difficult to go behind a car and overtake. So what the changes are, apart from the visual ones, that is the wheel side, it's going to change from 13 inches to 18, more like a typical car that we have these days. The biggest is the aerodynamics. So come back to the ground effect, and that means that we will have less wind, and that means less turbulent air moving forward. So the analysis that we are doing today is going to apply only until this year. After that, there will be other changes. We are working on that. So there will be other advanced machine learning workshops going through different algorithms. So we are cleaning the data. Something interesting here in this part of the screen is that we are modifying the names of all constructor teams. For example, in the past, we have Force India Racing Point, that now is Aston Martin. We have the old Sauber team, that now is Alfa Romeo, and we have Renault and Lotus that join into the Alpine F1. And Toro Rosso, that now is Alfa Tauri. So those are just cleaning the information. Depending on the type of information you are analyzing, you will have a different results. But basically, you are just cleaning all of that information so it's consistent, it's the same across the data frame. And now we are going to jump into some other information. It's really small for you. You probably have to look into that, but we are going to understand the concept of DNF. So DNF is did not finish. Those drivers that for whatever reason, either the constructor, the car failed for a reason, or the driver had an issue and failed. We are going to translate that into a did not finished concept that is going to allow us to understand if the failure was because a driver issue or a car issue. And that will tell us as well information about the confidence of the driver and the reliability of the car. That is very important for the race. So that's why we are printing. And then we are start plotting information to see visually who is the best, who is the worst in terms of rate for driver error. We are doing the same for the constructor. This is about the reliability of the car. Basically means that a flat tire, an engine issue, a power unit problem, hydraulic issue with the pressure, those type of things will fall in this category. As soon as we have that, we can start analyzing some interesting information as well. In this case, we are analyzing the drivers in the home circuit, how they perform. There are few drivers that are really good on those specific home circuits, either because they know the circuit very well, because they've been training since very young. So that is an interesting point as well. And we are doing the same for the podium, but also we are doing the same for the constructor. So some constructors, like for example, Mercedes, Red Bull, and Ferrari, they are doing really well when they are in their home circuits, either because they have the fans pushing, giving that extra power to the engine, or because they are motivating the driver to get a good result. Now we have all the data that we need. We are going to store it in a file, and that means that we are done with the analysis of the information. Now, without seeing the mouse, I'm going to try to share again the screen. Coming back to the presentation, and now we jump into a pause. I will give you 5 minutes to explore the labs that we just walked through. Lab number 2, 3, and 4 on your own. Post your questions on the Slack channel and see you in 5 minutes. Let's see how all of you are doing. Let's launch a poll to check if you have understood lab number 2, 3, and 4, if you feel familiar with the content in those. And now we are going to go to the next one, that is the important one for machine learning. This is where we are going to go through the algorithms that we are going to use. And it's very interesting. I will take it very easy, very slow on the next one, because I want you to understand the machine learning models that we are using, and that is very, very, very important. So just checking the pool results on your own time, keep working on the different labs, and we will jump into the lab number 5 in just a few seconds. Okay, the pool is stable already. Nice, let's jump into the implement the machine learning models. So let's jump into the browser once again, and we are going to go to the beginners folder, and then in this one we are going to work on 04 ML modeling. Let me close the ones I'm going not to use, and okay, bear with me for a second, because this one is the most important part for the workshop for you to understand. We are going to cover 6 algorithms. We explain all the content here, so you should go through every single word in this notebook, because it's explaining what all the algorithms are doing, what are they doing best, and basically I just want to do an overview of them. The first one, the classic logistic regression using the logistic function. No issues there. It's explaining what is good about this one, but basically it's the simplicity. It's a binary one, so it's going to push the values into 1 and 0. And the most important part is that it's very simple. We are going to use the decision tree and also the random forest that are related. So let's go to the section where we compare them one-to-one. So I want to explain a little bit the difference, just in case you are completely new to machine learning. So we are trying to understand the data and start learning from that data from the point of view of the computer, the machine. So we are going to analyze features that are those data points with different features of the information, and a decision tree will be as based as, okay, I have these features, I need to take a decision. I will go left or right. That is exactly like if you go in the nature, and then you have a pathway, and then suddenly you have like a fork that take you left or right. And based on the information you have to take that decision. Imagine 3 features. We are talking about the weather conditions, could be rain, and it could be the wind speed, but also could be the color of my t-shirt. So you really need to take a decision based on that information, and then go left or right, and you learn from that error if you go right and it wasn't the right one. And then random forest is a little bit more specialized. Imagine that, well, the color of the t-shirt doesn't really make sense if you want to go left or right. It's not going to be that relevant. So what random forest is good at is that it's going to pick randomly some features and run the decision tree on those. So that is interesting, because we are going to have a variety of features, and we are going to spot which one are more relevant and which one are less relevant. And then we are going to have the decision and the learning process from that left-right decisions and error measurement. That is the biggest difference between the decision tree and the random forest. Now we have the support vector machine that is a little bit more complex in terms, because there is a little bit more mathematical concepts behind, but explain it very simple. If we are in 1 dimension, we have just a line, then there is a point that is going to be the threshold that is going to allow me to decide left or right, or in this case, red or green. So that is our feature that we want to predict, and then there is a threshold. Imagine that instead of 1 line, and we have to define a threshold in that specific point, we have like 2 dimensions. We have a x and a y, and then we have, I don't know, h, and we have the height. So in that case, instead of a point, will be a line. And that line will segregate the information into red or green. And at some point, we can have more variables, more features, and that will be when we need to work with planes. A plane is just basically like a piece of paper that is going to just, once again, segregate the information in the two categories that we have, red and green in this example. A vector is a nice mathematical way to represent planes and in multi-dimensions, and this is where everything goes a little bit crazy, but basically it's a way to modify the parameters of that plane, that vector representing a plane, to be able to classify the information. That works really well with machines and is, as you see in the definition, is good for high dimensions spaces and so on, because it's really fast in those cases. Then one of the algorithms that everybody is talking about in one way or another is the naive Bayes. Basically, we are going to use the Gaussian one, but basically it's working with probabilities. It's just working with the histograms of the information, and based on the probability of those cases to be true or false, then it's going to calculate probability, and that is going to give us a learning way, a process to learn how to classify some data points. And then probably a simple one to explain is the key nearest neighbor. In this case, if we have that information, x1 and x2 in that plot, we are going to have green and yellow categories, category A and B on the example on the left. And then we are going to add a new point. That point, we don't know what it is. So we are going to try to understand what could be. And the way to do it is to select what other points, data points, are closer. So in this case, it's closer to the green ones. So it's deciding that it's a green one. And then there is a point where if it's right in the middle and you are having a hard time, what you do is you define a hyperparameter that is just a parameter that we say the name is k. That is where the name comes from. And that k will be the closest number that we are going to understand, to analyze. And that is like a voting. You are going to vote. Okay, from the 10 that are closest, where are you? You are in the green box or you are in the yellow box. And depending who wins, then that means that that will be either a green or a yellow category for that new data point. So those are the algorithms that we are going to use. Something as well interesting that you have to learn in one way or another is to analyze the data. We have done a little bit of that in previous labs, but basically is to print the information. I'm really a visual person, so I really love this part. When you are plotting the information, you really see the trends, you really see what is happening with the data. So those are the type of plots that we usually use in machine learning. So a scatter plot for different data points in a graph, the histogram, how frequent different variables are, and then there are others more complex like the heat map or the box plot that we are going to use in the future in this workshop. And then another important concept for those of you that are new to machine learning is the splitting the data set. So you have a big data set, the bigger the better, but you are going to use part of that information for the training part, and then you are going to use another part for the testing, for validate your learning. So that is very important, because what we are trying to understand is like all the models are incorrect, but some of them are useful. We are trying to find the useful ones. So for that, we are going to evaluate the model. And what we are trying to do is, and this is an important concept of machine learning, is the underfitting and overfitting.
Sorry, Victor, to interrupt you.
Sure.
There is probably the microphone is growing on your shirt. So actually, it's giving noise. Okay, thank you so much.
Yeah, let me know if it continues doing that. So I'll change the microphone, maybe changing to the laptop one. It will be like an echo, but maybe it's better. Let me know how it goes. So underfitting, we are splitting the information in training and testing, and we are trying to identify how good we are with that algorithm. Underfitting will be that we do very bad whatsoever. So that is underfitting. It means that you are doing pretty bad in all the learning, and that means that you have to improve that algorithm with the parameters, with how you learn, and then you move to the other concept, that is the overfitting. Overfitting will be that is so good, but only for the training data. So that first split that we did on the information, we are really good at that. But when we are testing in a new set that we know the answers, so we are using it to validate the other, then we don't perform that well. And that is equally bad, because we are actually performing really well on a specific mock data, but we cannot predict the other new data points that we are going to get in the future. So it's a thin line. That is where machine learning starts to become a little bit like an art, where you have to make sure that you understand there are different tricks on how to avoid the overfitting, but important concepts on that, and you will find them when you are reading through all the documentation, is the bias and the variance. It's really important concepts that probably outside of the scope of the presentation, but it's really important to understand the difference between the bias and the variance of the information. And now, finally, thank you for your patience. We arrived to the code. So there is not really a lot new to mention in this, but basically we are importing a little bit more libraries, basically the ones that we are going to use to do the different algorithms. So as you can see, we have here logistic regression, random forest, SVC, decision tree, key neighbors. All of those are the algorithms that we are going to use. And some helpers like the cross-val score that I will explain in a few seconds. Now, nothing new is what we have done in other labs. We are reading information from the previous stage, the data that is filtered and ready to consume. We are going to print it, make sure that everything has been read and everything is the way we want. We are going to make sure that the side of the data is correct, that it makes sense to what we expect. And then we are going to start working on the different information that we are going to use. One interesting feature that we want to analyze, and we mentioned before, is the confidence of the driver. So that is based on the times that the driver hasn't finished because of an error. So we are going to group the data by driver and then get the total amount of races that that driver has done. And we are going to use that information in combination with the times that the driver didn't finish. And that will give us a DNF, a did not finish ratio, that is going to be exactly the confidence of the driver. If I've been failing at many Grand Prix, I will be not that confident during the race. So this is the way we print that information. And we can see that there are different values. For example, Jenson Button has a 94%, and you can have different values ranging from 80 something to 90 to 1 in some cases. So that is the level of confidence that it's really important to understand. And then we are going to do exactly the same with the constructor. That is the reliability of the car. Basically doing the same. We are going to get the data, group it by constructor, and then get the information of the total number of races and the ones that had an issue due to a constructor error. And in that case, we are going to create the did not finish ratio for the constructors, and we are going to print it. So everything makes sense. And you can check, like, for example, Mercedes and Red Bull are 80 something, and others like McLaren is 61%, or even Marussia back in a few years back, 16%. So that information is really relevant. We are going to aggregate that information into our data set and start working with the active constructors and the active drivers, because we don't want to get the results of Niki Lauda, for example, as driver that is not anymore a driver. But that is just a way to filter this information. We are going to use a Lambda function that is basically an anonymous function in Python that is going to just decide if the information is an active driver on an active constructor or not. Then we print the data, and that looks really good. We have the columns. All the columns are good for us. And then we are going to start working on the model. So in this case, we are going to make sure that we understand the information and we start working on the preparation for the machine learning. And if you see here, we are going to get the information for active drivers. We are going to create the standard scaler and label encoder. What is that? Basically, machine learning is going to work with values. We don't need a driver called Jensen button. It tells us nothing, to be honest, from the machine point of view. So we are going to transform all of that into numbers, and those numbers we are going to normalize. So normalize means that the value will be between 0 and 1, and that means that it's easier, because if not, bigger numbers, like imagine we are talking about the number of races that a person, if someone were there for many years, it's going to look better for the machine if we leave it like that. So we normalize, so everybody goes between 0 and 1. So that is where we use the standard scaler for normalizing, and the label encoder for converting labels like text, like names of circuits, names of drivers, into values, 0, 1, 0.7, whatever is the value. So we are going to do that, and then at some point we are ready to start working with the cross-validation of different machine learning models. And that means that we are going to create the different models that we are going to use, back to the 6 that we mentioned at the top: logistic regression, decision tree, random forest, etc. We are going to put the names as well, because it's going to help us to print that information later. One interesting part that we are going to cover is this function. So we go through every single model and create a cross-validation that basically is telling, this is the model, this is the data, tell me how good we are. So the scoring will be the accuracy of that. And we are going to print it in one way or another. And we see that logistic regression, decision tree has different levels of accuracy. And that will tell us that if we plot that information, it's going to tell us that some do better than others. So for example, in this case, we have this one that is the random forest that is on top, but we can analyze as well that the Gaussian naive Bayes is not doing that well. So we can understand which one is the best for our case, and we can move forward on that direction. We are going to do the same with the constructors. So in this case, we are going to analyze the information from the constructor point of view, doing basically the same code, and we change the data that we are plugging in. And in this case, we are once again analyzing the results. And once again, we are between the SVC, the support vector machine, and the random forest. So this is an exercise that probably we don't have time for you. So what I'm going to do is to copy the results from the REST folder. But basically, we are doing the same with both drivers and constructors. And that is the interesting part. That is where we want to use our machine learning models and learn which one performs better. So I probably execute it or not, depending on the time. I have to check it. But basically, you have these empty cells that you can fulfill and do the cross-validation and implementing the block spot. So I'll try to do it. And then we jump into the model that we are going to use. Okay. So I think I have time. Let's go really quick. I'm going to get the res, open the one that I want. That is the res, the solutions. And you will see that here we are working with this as the same file, just getting a little bit more information about the constructors and drivers. So this is the code that we want. The clean part is there, I believe. Yeah. So that is the way we clean the information. And now we are going to jump into the data set that we want. So the X is for the information we want to train our data model. So let's copy that. If I were you, I would try to do it on my own first. And when I fail, if if you fail. Then I will go to this, but just for saving a little bit of time. So now the next one is to filter the data set. So if we go to here, we are going to get active drivers and active constructors. You see, it's very similar to what we did before in the constructor and the driver separately. So it's just merging both things. Then we paste that. Now we go to create the standard scaler. We know about this now already. So it's to scale the numbers, to normalize them, and the label. So we are going to do that in GP name, constructors, drivers, etc. Let's put this here. And then the final step will be to prepare the X, the feature dataset, and the Y to predict the values. So that implement X and Y will be those two that basically are getting the information we want. So we are moving from the position active driver, active constructor into a position. Let's move that. And I think that is all we have to do. The cross validation, we are going to copy this, but we also can just go and check the results here. And probably is what I'm going to do anyway. Plot will be just that. And then I will just leave it running. So you see how I run the different notebooks. So in this case, I'm going to plot the results. And in this case, what I'm going to do is to restart and execute the whole thing. So I click there and then restart. Start kernel. You see, now it's busy. It's doing all the cells one by one. You can check it because it's moving across this. You will see that it's doing the cross validation. It's getting the results. It's plotting the values. All of this is new information that we are getting. Random decision forest now 94. The rest of the algorithms. That is how we execute all of this. And that is all for this specific part. This is the graphics that we are going to understand in terms of analyzing which one performed better. So we see that the red one, that is random forest, is performing very well across all the information from only drivers, only teams or constructors, and the combined data. So that means like we have made our minds. Looks like random forest is the one to do. So in this case, let me come back and share the presentation. And we are going to work with the model serving. So now that we have decided which one we are going to use, we are going to use the parameters, we are going to find all of that information and then serve it. So it's ready for consumption from the UI point of view. In that case, let's come back to the browser. And now we are going to jump into model serving. Model serving, if we come back and close the ones we don't need, we go to 05 ML modeling, and we are going to understand that first, as usual, we import libraries and then we get the information. The only difference here is that we are going to use a library called Pickle. Pickle is going to be able to serialize an object in Python. So that is the way we store a binary with the model, the machine learning model, in a file. And that is the file that we are going to use later. Okay, so let's get the data filtered. And now we are going to print the information that is very standard. By now, we know that we are going to calculate the driver confidence. We are going to do the same with, this is the different confidence for the drivers. We are going to do the same with the constructors. That is just a replication of what we have done before. And then we are going to analyze the team's probabilities after last race. So this is analyzing the information for 2021. So we are going to go to a specific race and see and check and validate that everything works the way we want. I don't want to spend a lot of time because this one is already something that we have covered. It's just printing the information we get from the difference with the points. That is something that you can take a look. There is no new code there that you are not familiar by now. The points by constructors, and it's going to analyze all of that information and generate a qualifying data set for the predictor. So basically, we are trying to understand how good we are. And finally, we are going to generate the machine learning model. Random forest is the one that performed better. So we are going to create a function to save the model that is going to use the pickle library to work on the to store the model in a file. Now we import the libraries. Nothing new here. In the cross-validation score, we are going to get the logistic regression, the random forest. We are going to basically do the same. But the most important part is that we are going to calculate the parameters for the random forest. And that means some, depending on the library, but basically you are going to create some parameters to work with that. And then we are going to read the information, start working with the active constructors and active drivers, something that we have done in the past, but this notebook is standalone in that terms. It just get the data, the general data, and apply the random forest. This is where we created a random forest object. And we are going to start fitting that. That is like the learning part. This is where everything happens. We pass the information, pass the results, the learning, the supervised values, and then we are going to get the best parameters. That is from the random forest object. And we are going to see that the number of estimators, the number of samples split, the leaf, all of that is information that is where we perform better. And now we are going to create that one, store it, get it ready. And after we have done that, the confusion matrix and all of that information, feel free to take a look there in that code. We are going to save the model. Okay, so we are going to save the model in that specific folder with that pickle extension of the file. And that is a binary file that contains all the information to use on the website. As soon as we have that, we are going to analyze some information that is very interesting in that specific case about the features. So there is a nice graphic here that I want to cover. This looks like after applying the random forest algorithm, we see that the qualifying position, so the position you get of the grid on Saturday sessions is very important. If you are at the top, it's probably because you are faster, and that means you are going to end up at the top the day of the race. That is no-brainer, but that is a validation that our machine learning makes sense. That is something that you have to think as well when you are creating your machine learning models. Something that is as well slightly important, although a little bit far away from the qualifying position, is the driver confidence and the constructor reliability. If the car is going to fail, there is nothing to do. Even if you were in pole position at the top of the grid, you still have problems on your way. And the driver confidence, that apparently is very important. We were checking that in the exploratory lab because we understood that even something as simple as racing in your home circuit is important. So the confidence and the mindset of the driver is very important. Then there is really just an overview of how we even plot how everything was analyzed from the random forest algorithm. So you can understand the colors are the features, and you can understand how everything was executed. And then at some point, we can just analyze the estimators, different estimators, how that learn in different ways. And finally, we are going to see the results in the last part, that is the UI part. So at this point in time, let's come back to the presentation. And I'll give you 5 minutes to explore these two labs. They are the most important parts, so feel free to go through them, understand them, and implement the machine learning models and the model serving. Post your questions on the Slack channel so the team can help you, and see you in 5 minutes. let's see how all of you are doing. Let's launch a poll to check if you have understood labs 5 and 6. We'll use this pause just to remind you we have compressed 5 hours of content in just 2 hours. So I just walk through the content so you understand and you can start making your changes on the code and feel familiar. Even I invite you to test with the latest information from Formula One. Check if you can change the application as well, that we are going to just cover in a few seconds. So the code is there. You have created your cloud account. That is where you can have some issues and benefit from a team helping you. You also have your stack with all the environment ready to go, all the information. You know how to access, you know how to read the code, you know how to execute the code, and you can move from different folders and understand what is there. So that is very, very important for you to do. At this point in time, I'm going to show you the UI part. And basically, let me just go to the browser again. And in this case, what we are going to do, and I'm just checking the pool. Yeah, all good. Yeah, everybody is moving forward. Very good. We are going to open a terminal here inside of the Jupyter Notebook. So let me clean this a little bit. If you don't have a launcher, and this is the place where you landed at the beginning of the workshop, you can always click here. That will open the launcher, new launcher. And in this case, you have different options. You can create a new notebook, something that I really recommend you to do, and start playing with the libraries. But another important for this specific lab, the UI part, is to open a terminal. And then if you list the files you have there, you will see that you have 2 executable. One is the launch app SH. So let's execute that. And this is all as well steps. If you don't feel familiar with the Linux part, all the steps are in the content of the workshop. So I'm just going through the step, and the first one is launch app sh start. It's not going to return anything. It's just execute it. If you get any error, this is the point where you will get it. But that means that the application is also launched inside of your virtual machine, the one where Jupyter Notebook is being executed. So I can copy the public IP because it's going to be the same host, but a different port. Instead of 8001 for the Jupyter Notebook, I'm going to use a different port, and that will be same IP, semicolon, 8080. 8080 is the port where that application is running. So here is the application, Formula One predictor, and we can select the different circuits. So I'm going to select Monaco in wet because I think that is fun. And I'm going to predict the results. And it's going to tell me that Max Verstappen with Oracle technology and Red Bull Racing Honda is going to win that race in that conditions. But you can play around and get different results. So for example, if you go to, I think another interesting is Hungaroring, but Silverstone. Silverstone in warm conditions, and we are going to get that Lewis Hamilton is going to be on top, and then Max Verstappen and Bottas on third place. So that is the way we consume the service. And this is the way you can put your machine learning models into production. What is very, very interesting is not that you can create a machine learning, is that you can leverage that power in a website. So this is the final step to consolidate all your work that you can do. You can always stop this one. So for stopping, I'm going to actually go through the history, and instead of start, put a stop. And this is the way you stop the web from working. Yeah, I think that is all from the demo point of view. Let me come back to the presentation. This is as well a good part for you to catch up with all the content that we have exposed. And then I'll give you another 5 minutes to explore Lab 7. the UI access to catch up with everything else. If you feel like the most important part for you was the 6 algorithms and that part of the code, that's fine. If you get there and spend more time now, we can going to support you, and I will check all the questions for the next few days. So feel free to come back and let us know how you are doing. If you are doing something amazing with this content, I would like to know as well. So see you in 5 minutes. We are at the end of the event, so let's check next steps and recap. Basically, before Ettore come back and wrap up the event, I want to say thank you to all the panelists, first of all. But I love to learn, and this has been a lot of fun. I hope you have the same feeling, that you have learned a lot about the basics of machine learning. Now you have all the code, you have the environment up and running. You can start spending time with this code and get to know machine learning, how to apply it, how to put it in production. So yeah, I know you have hearing my voice a lot this morning. So thank you so much for your patience. And now it's time for you to enjoy. Ettore, you can join me here.
Yeah, of course, and thank you, Victor. So this is the end of the race of today. Let's say the race was just for Victor. As I mentioned into the chat or in private conversation with some of you, this is not a race. So we are here because you need to benefit of the expert that can support you and drive you. So for this reason, we created this Slack channel where you can continue to post and raise your question. The information we shared today are public, so you can benefit and you can go ahead practicing the content. There is a recap here of again of the bit link, but you will get also again, if you check the reminder email, there are the same link there, and we will send a thank you mail also with the link to the record of the today's session. So here you have additional resource. I put it into the chat the link to our feedback survey. For us, it's relevant that you share your comment, your feedback. We can just learn and improve, okay, what we can do better. And then here you have a link to the next masterclass, UpDev Masterclass. This is part of an umbrella program that we are running for the developer community in Europe, Middle East, and Africa. So the next one will be the 11th of November on how to deploy Apex application and combine digital assistant on it. So it's pretty nice, and it will be 2 hours where you can learn something more or discover something different with Oracle. Then there will be another event that will come on Red Bull Racing. So my advice is to follow this developer.oracle.com/Red Bull page, where we are going to post the new session. Will be at the end of November, this one. Then again, the lab guide and the Slack channel, no, for you to be in touch with us. Last but not least, you will get this bit link to participate to a quiz that is based on the content that we shared today. So it's an easy way to get your digital badge for this session. And I hope that you will enjoy and you will share and create buzz on the social media channel you own. And last but not least, I think it's very, very important and interesting for all of you until the end of the calendar year, so the 31st of December, there is a bunch of training and session, training and certification that are free. So our Oracle University program is pretty good at the moment. I advise you to get the page and understand, because it's really about you in this case, in my opinion. So there is the possibility to you to be certified on Oracle OCI on different matter, and of course you can grow the skills, and you can grow your curricula and insert new possibility in your career. Okay, so I advise really to take a look on this, and are for free until the end of the year. And we are really now at the end. So thank you to all the panelists that are supporting you in the Slack channel. Really good insight also from that part. But at the end, thank you to you, our guest, to participate to today's event. I hope that you enjoyed the content, and speak to you soon.